everyone. Today's lesson is on translating verbal expressions, which is really just a fancy way of saying we're going to take words, sentences like these ones on your paper. This paper, by the way, is located inside your notes packet. Taking words, verbal sentences, and translating them into algebraic equations. Literally translating, like you would translate from a foreign language. If you're translating from English to Spanish, it's the same process. And I start the year with this process because I find that in Algebra 1, word problems are probably the most intimidating thing students face. Anytime I hand out an assignment with word problems on it, I hear, oh, I just don't get the word problems, they're just way too hard, I don't even know where to start, etc., etc. When I would say 90% of the time, the problem is way easier than you think that it is, and it's just the fact that it's surrounded by all of these scary words that kind of makes you freak out. And so I want to give you some strategies to combat that. I want you to be able to tackle a word problem and dissect it and pull it apart and make it something more manageable. Now I know some of you are probably thinking, oh my gosh, translating this into algebra is not going to make this more manageable. Okay, it's going to make it harder. But I find that with most students, once they get it into an equation, something that they know what to do with, something that they're familiar with, they're way better off. And they are able to take it from there, and they don't even need me anymore. It's just that first step that is always difficult. So that's what I'm going to show you today. I'm going to show you this process that I kind of go through on some very basic problems. These problems that you'll find on your page are really, really basic type questions, just to get you an idea of what I'm asking you to do. Some of you are going to read these problems and go, oh my gosh, I know how to do this in my head. Why do I have to go through this whole process? I'm glad you know how to do it in your head. I really am. That means you have really good math reasoning skills. But really the goal today is not for you to get the answer. I don't care so much about you being able to get the answer. I care about knowing what to do with the words and how to translate them into something mathematical so that you can do something else with them later on. And that process is going to come up over and over again this year. I'm not necessarily going to make you break out highlighters and everything every time we do one of these, but if you do this enough times, you'll sort of internalize it and you'll know what to do. So I'm not trying to make it harder on purpose. I'm not trying to make it be more work for you. I'm trying to give you a strategy that you're going to find useful later on, I promise. So you'll see up in the corner of your paper, I've written equals is blue, variable is pink, operation is yellow. If you want to jot that down, you're welcome to. I took that right off of your homework assignment, the directions from your homework assignment that you'll be doing after we do these examples together. I just didn't reprint the directions on this sheet, so I thought you would want to know kind of what the key was. What I asked you to do in the directions was, in each problem, find the word that indicates equals and highlight it blue, find the word that indicates the variable and highlight it pink, and then find the operation words and highlight them yellow. So today, all you're doing is highlighting. Okay, we'll work together later on to then take that highlighted sentence and turn it into an algebraic sentence. But for now, you're just working on the highlighting and the finding the correct pieces. Okay, I'm going to shut this off because you don't need to stare at me the whole time. Okay, so one of your assignments this week was to go on that website called Lino It, and with your group and put together a table of some operation words. And one of the words I asked you to try to find was, what words in a sentence indicate equals? And I will tell you, because you may not have been able to think up this one on your own, most of the time it's going to be some variation of the word is. Okay? Is in math always means equals. Because if you think about it, like if I were to write the sentence, the sum of 2 and 3 is 5. That sentence, if I were to take that and write that as an equation, would look like this. 2 plus 3 equals 5. So the sum, that's your addition, 2 and 3 go there and there, is 5, equals 5. So is almost always your equals word. Now, is shows up in a couple of other forms. If it's in the past tense, we say was. And if we're talking about more than one person or thing, instead of saying she is, we say they are. So any one of these is just a variation of is, and that's going to be your equal word. And we're going to start with that. So I'm just going to skim through each one of these and look for that is word. So for the first one, 3 times the number increased by 12 is 24. There's my equal sign right there. Okay, when I go to write my equation, that's where my equal sign is going to end up. Number 2, the cost of 4 folders and a binder is $13. Okay. By the way, I would ignore, like here it says, what is the cost of each folder? That is sort of part of the question, what it's asking you to find. Technically, it's saying what price is equal to the cost of the folder, but that doesn't really set you up your equation. So we'll come back to that, I'm sure, when we're writing equations. But Jake earned $20 cutting his neighbor's lawn, which was, there's that sneaky is in there, for more than double what his brother earned cutting their parents' lawn. Okay, so that's where your equal sign is going to be. You're going to have this stuff over here equal to this stuff over here. Amani spent half of her weekly allowance playing mini golf. She walked her dog, earned $4 more. The total amount she had left at the end of the week was $12. So all of this is going to be before the equal sign, and it's going to equal 12. That's what that tells me. And then if I look down at this last one, I believe, does not have the word is, the literal word is. But here it says altogether they scored a total of 3 touchdowns. Total is another one that can sometimes mean equals. In fact, a lot of the times it means equals. I would say is way more common, but in this case it's total. So if those words aren't on your group's website yet, it might not be a bad idea to go back after you watch this video and add them. See if you can be the first one to do that. Okay, the next thing we're doing is the variable. And in algebra, we use variables for things that we don't know. But not just anything we don't know. It's the thing we don't know and we're trying to find. And I'm going to come back to this a lot this year, the idea of defining the variable. Because you can't find what you're supposed to find unless you know what it is that you're looking for. Okay? So, and that's what we're going to represent with our X or with our whatever letter you feel like using. So in number 1, and the answer to this question, by the way, is almost always at the end of the sentence, okay? Or the end of the question part of the sentence. So like here, for example, 3 times the number increased by 12 is 24. Find the number. So the number is what I want to know. Okay, but I'm not going to highlight that here because that's just telling me what to find. I want to go back and where it's giving me all the information and find where that number shows up. So you see right here, 3 times a number. That's my variable. So I know that is what I'm going to represent with X. Okay. In number 2, again, I'm going to jump to the end of the question. And what it's asking me to find is what is the cost of each folder. So the cost of each folder, that's what I'm going to represent with X. Be careful in questions like that. Some students, when I say, what are you trying to find? They'll say the cost. Well, the cost of what? The cost of the folders, the cost of the binder, the cost of a cup of coffee. Okay, so be specific there. So the cost of the 4 folder, or the cost of each folder. So I guess I'm going to kind of do, well, okay, the folders, but we want the cost of each folder. Is what our variable is going to be. I don't want to highlight the 4 because I want the cost of each folder. I don't want the cost of the 4 folders. That'll make more sense once we're writing our equations. Okay, number 3. The question is asking me, what did Jake's brother earn? Oh, and back here, I do this all the time. I did not mean to highlight this. Okay, really, you just want to highlight it in the question. If it helps to like underline that or something, go for it. But okay, so here I want to know, what did Jake's brother earn? Okay, so I'm going to read this whole question and look for where it talks about what Jake's brother earns. Okay, which was 4 more than double what his brother earned. Okay, that's what we're trying to find, so I'm going to highlight that in pink. Number 4, our variable here, what we're trying to find is the weekly allowance. So I'm going to go back into the information part of the problem and find her weekly allowance. There it is right there. Amani spent half of her weekly allowance playing mini golf, blah, blah, blah. And you'll see, by the way, remember down here I told you total could mean equals? Total shows up here too, and it says, I could paraphrase this, I could actually leave all of this out and just say the total was $12, so those two kind of go together, okay? Just like when you're translating from one language to another, not everything translates super smoothly. Okay. And in the last one, my question is, how much did Brett score? So if I read through the question, last season Michael scored 3 less than twice the number of touchdowns Brett did. So when I say how many did he score, it's the number of touchdowns that Brett scored that I'm looking for. Okay? So I've highlighted all my X's. Those are all of my things that I'm trying to find. Now I want to search out my operation words. And the operation words, those are what hopefully you and your group were able to put together on your Lino board. Those are words that indicate some kind of mathematical operation. So like plus, or words that would mean addition, subtraction, multiplication, or division. So let's take a look through here, and hopefully you found some of these already, but if you haven't thought of yours yet, after we do this sheet, you should have some ideas. So in that first one, 3 times tells me to multiply, so that's an operation word. Increased by, that's an addition word. Okay. Down here, the cost of 4 folders and a binder is 13. This one really, the operation words are really sneaky on this one. First of all, the cost of 4 folders, and if I want each folder, I would be taking the cost of each folder and multiplying by 4. So there's sort of a multiplication implied there. That one's a tricky one for operation words, okay, because the cost of 4 folders tells me I'm going to do 4 times the cost of each folder. And then I'm putting that together with a binder. So I'm doing the total cost of folders and a binder. So I really don't want to highlight the word and, because and does not always mean addition, but in this case it's telling you that you're going to end up multiplying there. Okay, you're going to end up adding, I'm sorry, I just said multiplying. It tells you that you're going to end up adding there. You're going to be doing the cost of 4 folders and a binder all together, and it's going to be $13. Hopefully that makes sense. We'll talk more about that in class if you're confused. Number 3, let's look for some operation words. Jake earned $20, which was 4 more than. That's an operation word that means addition. And then double is another operation word because that's telling me to multiply by 2. I think that's it for that one. Okay. In number 4, Amani spent half of, and I'm actually just going to highlight the word of. If you highlighted half of, that would be okay too. But because I want to draw some focus to the word of almost always means multiplication. And it means multiplication specifically with fractions. So if you look at half is a fraction. When you say a third of something or 2/5 of something, the of is a multiplication word. So in this problem, we're going to end up doing 1/2 times the weekly allowance. Okay? Then later on, she walked the dog and earned $4 more. So again, that more than, I'm earning 4 more. That's being added. That's addition. Okay? The total amount she had left was $12. Okay, so we're good there. And number 5, Michael scored 3 less than. That's a subtraction word. And then twice. Twice is kind of like double up here. Twice means I'm going to multiply by 2. So there's 2 different words there. The number of touchdowns Brett did. Altogether, they scored a total of 3 touchdowns. I'm going to highlight one here that's kind of tricky for some people. Altogether, almost always, can't say for sure, but almost always means addition. Because altogether means you're putting 2 quantities together and combining them. Okay, so now that you've got these 5 examples in front of you, and I'm going to zoom it out so you can see all 5, your goal is to head over to your homework assignment tonight, which is a worksheet that says From Words to Equations. I think that's what it's called. Yep, From Words to Equations. There are 8 more problems similar to these, and all I'm asking you to do tonight is this highlighting. Okay? So just come into class with your paper all highlighted, just like mine is, with the same kind of code, and that is printed on the top of your paper. And then we're going to talk tomorrow about now how to take all these pretty colors and turn them into algebra. Okay, email me if you have any questions. Thanks.